have a very special guest with us. He's joining us from United States, and he is a professor at Carnegie Mellon University. He will be showcasing a project that he has been working on. I wouldn't disclose the details right now, but I will share about Roger, who's here with us. Roger is a professor at Carnegie Mellon University. He is a music composer. He is a computer scientist, and his projects, you might know a few of them, like Audacity. And then there are multiple projects, and the one project that he is going to showcase today, that is one breakthrough that he is going to tell us what is it about and how he built it. So it's going to be a very wonderful session for learning and get to know that what's going on in this space. So without further ado, I will hand over the screen to Roger.
All right. Hello, everyone. Again, I'm Roger Dannenberg from Carnegie Mellon University, and I'm here to talk to you about Soundcool and also a few words about just software design in general and what we're up to. So let me share the screen here and we will get started. Okay. Okay, I hope this is working. I'm going to assume so. Okay, so Soundcool is a collaborative computer music creation system. And first of all, let me try to give you some idea of what Soundcool is really about. So Soundcool is a modular software system for creating music and sound, for manipulating sound. And the basic idea is that Soundcool comes with a bunch of ready-made modules like this signal generator and a mixer, and you can hook them together, and you can hook the output up to your speakers and control sound. The second thing that's kind of interesting about Soundcool is there's Wi-Fi interfaces to mobile devices and a Soundcool app that looks like this. So when you hook this up to Soundcool, you can control sounds and manipulate things on the touchscreen. So hopefully, yeah. So we're making some different sounds here. And we can make some even more dramatic sounds or some beautiful, cool sounds. So what is Soundcool for? It was actually designed for music education. One of the very interesting things about Soundcool is it allows many people to collaborate because of these mobile device interfaces. So working together in the classroom is a very musical thing to do and a very educational approach to electronics and sound. Another thing that I've been spending a lot of time on over the last few years is co-writing this opera, The Mother of Fishes, with co-composer and Soundcool leader Jorge Sastre. And I want to play a little excerpt of this. This is a scene from the opera where the hero is fighting a dragon with his sword, and you'll hear some whooshing sounds that are created with Soundcool, and also some electronic sounds, big electronic sounds that complement or blend in with the orchestra. So here we go. Another application is in live music manipulation. And this is a piece called Chapitrace, which is for a wind ensemble and narrator and live Soundcool processing. So if you listen carefully, you'll hear Soundcool is capturing some live sounds from the band and manipulating it. Let's give it a listen.
El susurro de esperanzas no cumplidas y entre sollozos dormidas.
So I wanted to say a few words about some of the things that I think make Soundcool interesting and that might have some relevance to other software projects, especially software that's made for end users to do creative things. And so these three ideas are having components with ready-made interfaces, offering support for plugins, and providing interfaces for external control. And so I wanted to go through these ideas very briefly. The first one is components with ready-made interfaces. So what does that mean? It means that when you build an application, you also build the interface, because in Soundcool, each of these modules are bundled together with a graphical user interface. Often in programming, you think of building the program or building the functionality and then building an interface so you can control it. And one of the neat things about Soundcool is as you're building things and putting modules together, the interfaces are right in front of you. They're packaged together so that users may not even realize that there is any separation between the interface and the function. And that I think is very good for prototyping and just making things simple. The second idea is support for plugins. So I've been building computer music systems for decades now, and one of the things that I've tried to do in earlier projects is build very comprehensive systems. You have kind of one environment or one working area where you can do everything, and there's some reasons to think that that's a good approach, and there are some examples, and there's nothing wrong with them, but I think users are happier to find off-the-shelf components that are just ready to go. And so the lesson here is that if you can support plugins, maybe you can inherit lots of good stuff for free. And to show you how that works, in Soundcool, we leverage a plugin standard called VST. And if you want to add one of these plugin components, you first instantiate a Soundcool VST host module. And with the load button, you can select which plugin you want. And then with the open button, you open up the interface that comes built into the VST plugin. So, for example, this is a sort of analog synthesizer emulator plugin that's available for free. And you could make this entire synthesizer with many, many Soundcool components, oscillators and filters and mixers and so on. But it's certainly a lot quicker and easier if you're interested in this kind of analog synthesizer to just bring in the plugin, and you've got everything ready to go. And you can use it within Soundcool to make some stuff like this. And you might say, well, why not? Why do I need Soundcool? I could just download a software synthesizer and play with it directly. Well, with Soundcool, you can plug this into other effects. You can plug it into recording modules, so you can record things. You can mix it in with other sounds. So it's a very nice. Soundcool is a very nice toolkit for building things and putting things together. The third idea is interfaces for external control. So again, we could try to build a very rich language and system and provide for control within Soundcool. But what we've done here is provided an interface using a technology called Open Sound Control that lets you control Soundcool with anything on the outside. So one of those things is, again, the mobile devices and the Soundcool app. This runs over Wi-Fi, which is, of course, internet. And so one of the interesting things we've been doing is having collaborative performances with, the last one I did, the Soundcool was running on a computer in Madrid, Spain. I was in Pittsburgh controlling some things. Jorge and others were in Valencia, and we were all working and controlling together, and then we distributed the sound through Zoom, and you can find that performance on the Soundcool website. So mobile apps. The second thing is microcontrollers and sensors. So, for example, the sword that you might have heard in the opera was had one of these little sensors buried in it. This is a computer with Wi-Fi, battery, gyros, and open sound control all in one little unit, and it allowed us to do real-time control from the stage. And the third thing is programming languages. You can, with sort of any external programming language, you can generate the same kind of control that we control with these apps. And I wanted to show you one simple example of that. I'll try. Yeah, here's a little program. It's about 2 pages, and the main part of the program is just this loop, and we won't go through it in detail. But let me just say that it's a very, very simple idea of randomly choosing a sound to play every once in a while, and randomly choosing some parameters like delay and feedback to modify every once in a while. And it's doing the same thing that I could be doing by hand on this phone, but it's doing it very quickly and very randomly in some interesting ways. And we can run this now and just to hear what that sounds like. Okay, so we'll stop there. So there's lots of fun things to play with. The technology we use to build Soundcool is MaxMSP, which is a visual programming language. It looks, this is not actually Soundcool, but gives you some idea of what the visual programming language looks like. And for the mobile apps, we used Unity, the game engine. So that's about all I'm going to say here, but we can talk later. If you'd like to get Soundcool, go to soundcool.org. You can learn a lot more about the project and see what's going on. For future work, we are re-implementing Soundcool in the browser using web audio technology. And so it's web audio, React, and Redux in the front end. And we're using Node.js, React, and on the back end. And in the standalone version, SQLite. And for the server version, MySQL. But we have this vision that someday anyone that wants to play with Soundcool can just go to our website and immediately have all the software running in their browser, and they can share what they do with other people and maybe even perform together online. I was asked to say a few words about mastery, and I'm running short on time, and I don't have that much to say, but as a musician, I would say do what musicians do: practice, practice, practice. I can think of no better example of mastery than a virtuoso playing a musical instrument, and I can tell you from long, hard experience, the way you get there is practice. The second thing I would say is don't always take the easy way out. I see a lot of young programmers doing what comes easy, throwing things together, and maybe not actually doing what they want, but just doing what they find easy. And, if you're a musician, you don't get to change the notes if they're hard. You just have to practice and learn it. And the same goes for software. I'd say you should not always take the easy way out and pay careful attention to good design and good software and solving problems. And that's how you get better. So just to wrap up, Soundcool is easy to use, produces high quality audio, and we've talked about some software design lessons that I think would apply to other systems. And I'd like to thank especially the Polytechnic University of Valencia and all my friends there, Carnegie Mellon University where I work, and lots of organizations that have supported Soundcool. So with that, we're open for questions. Thank you.
Amazing. Thanks for sharing this, Roger. It's wonderful to see art and the software combining in one place. So we are getting thank yous in this questions, and they are appreciating the project, and thank you for the creations that you have done in the past and this one. I have one question right now. So that is, what is role of art in our life? As a computer scientist, how do you see art playing a role in life of a programmer or a computer scientist?
Wow, that's a big question. For me, I think art gives meaning to life. Maybe technology and science help us get there, but they don't really tell us what to do or why. And so for me, art is really everything.
Got it. Great. So how people can make this software? So you shared about this open sound control, and you shared about Unity. So these are a couple of projects that are there which you are using to build this. What could be the next thing which can make this kind of 3x, 10x better, or what future plans do you have for this?
Well, let me think. So one thing that's that I've been doing a lot of work on, and I'm interested in, are networking, systems for networking that make networking simpler. Right now, because of basically the history of how network technology developed, we have IP addresses, we have port numbers, and so when you want to talk to something, you either have to type in port numbers to make a connection, or you have to have some name service. But it's just kind of the nature of current commercial networking that people don't have fixed IP addresses. They don't have domain names for everything. And so just getting devices to talk to each other is kind of a challenge. And I've been doing some work in that area for projects like Soundcool. And I think we need more. I think the Internet of Things is pushing people to think about new ways of getting devices to talk to each other. Another thing is real-time or low latency networking is something that's been a long time in coming, and certainly for even for things like this, for this Zoom based streaming, it works, but the latency is really high. So if you and I were trying to perform music together, it would be very difficult. And of course, we have a speed of light problem going from the United States to India, but even going from one room in my house to the next room over a streaming service takes a big fraction of a second, and which makes music performance impossible. And I think we could do a lot better, and there would be some really interesting applications if we could push on that.
Got it. Amazing. So collaboration is, I think, one thing which we can learn from musicians, how well they have done. And this could be a good learning for programmers, how they can implement collaboration in engineering in their projects. So would you like to share more about the role of collaboration in building an innovation, or any learning that you had while building this project related to collaboration?
Yeah, this has been a really interesting collaboration, and in the I guess the biggest collaboration was actually writing this opera with my colleague Jorge Sastre, which I can't give him enough credit for pushing Soundcool and getting it out there. And we wrote this music together, but we are on different, he's in Spain, I'm in the United States. So it was quite a distance project. And it really impressed upon me, how the internet and all of the tools that we have now have just really changed life in some really interesting ways. More recently, we've been working on this web audio version of Soundcool, and there's a couple of developers in India. There's a team in Valencia, and a few of us here in Pittsburgh. One of my students has been in China since the pandemic, and so we're kind of all over the world working together, and we meet online with video and talk things over. We have source code, shared GitHub repository for code, and it's, I guess I don't feel like I have anything too special to contribute, except to say that you really can get together with friends all over and work together online, and it's been a really good experience.
And this becomes more important in the pandemic situation that we have, and your project enables that kind of collaboration, which was not possible before. One more thing, one question I have is when we talk about music, and it was quite closely related to issues with IP, that people create some music and then their copyright has been snatched or people are misusing that and so on. So copyright has a very good history in music. At the same time, you are enabling a collaboration where many people are creating their own IPs. So, how do you handle that IP in this specific software? Is it completely open? Are you keeping it completely open, such as MIT works, license works for open source projects? Are you thinking on that line, or are you thinking of creating or something for musicians which can give them more ownership of their content?
Yeah, well, let's first of all, I think it's important to separate the software and the tools from the content, or the music and artistic content. So the tools that we're building are free, and we have some sounds and some material that are free, but for the most part, we're trying to enable people to create their own music and create their own sounds. Now, many of the things that people build are using existing sounds and combining sounds. So, for example, even the little percussion sounds that I loaded here came, I believe, from now I'm blanking out on the website. Freesound.org. So friends in Barcelona actually are responsible for Freesound, which you can go to and find Creative Commons licenses for I think over 1 million sound samples, and they're kind of all tagged and indexed. And so a lot of our students go to freesound.org to pull up sounds when they're interested in finding sound effects, and there are rhythm loops and drum sounds and all kinds of stuff. And so and that's not the only one. So there are many sources of open source sounds that I would encourage people to explore, and then learn to manipulate them with Soundcool or Audacity or whatever your favorite audio tools are, and then you can really make it your own.
Amazing. I'm really excited to see the next version of this, where we can collaborate live here in the conference and give people control to create their own music in a collaborative way. I would love to see that in the next season, people using that. So all the best for this project, and thanks a lot for coming in here and sharing your breakthrough with us and taking out time to share your knowledge with the people here. So would you like to say any last message to the audience?
Yeah, let me just say one more time, soundcool.org if you want more information. I also, Roger Dannenberg, you're welcome to send me email. And it's been a real pleasure to share what I do with everyone here. And thanks for the invitation.
Amazing. See you then. Bye-bye.
Okay, bye.